Hello everyone, this is Construxo here with a demonstration of a light switch and controller I built. Here's the interface for it. 5 buttons, 3 brightness levels, an off and a reset. And there's a ready light which goes off when it's not ready. Then there are some indicator lights which indicate the current state that's activated. It's currently on level 2, second level of brightness. Let's go to level 1 from there. And it knows all it has to do is just pull that piston down and put the back wall in. And that's a real simple one. So if we go to level 3, however, from there, it has a few things to do. It's got to pull the glass out, and it's got to put the glowstone right up flush with the wall. So now, if we go and hit level 1, like we did last time, this time it knows it's got a few more things to do. It has to put the glass in and put the back wall down and all that. So each button does 5 different things. So for a 5-button system, that's 25 different things that this machine has to be able to do. If you had a 10-button system, you'd have 100 things you'd have to do, so that's just out of control. So however many buttons squared if you want to build this type of machine. So, and I have some fail-safes built in so that if you push a button and you push a bunch of other buttons before that light comes on, it won't mess it up. So let's check out the electronics. These are the clock leads. There's several different things the clock needs to do each time a button's pressed. These are the fail-safe AND gates. These are latches that hold the current state of the system. So those just, all that basically just turns the buttons into self-canceling levers. These are pulse generators that generate the main pulse for the system. These are delays that help with the memory of remembering the prior state. These are the heart of this, the activity selection are these D flip-flops with the data and clock leads. When I push button 3, there are, excuse me, 4 different things that will get activated, really 5, one down at the other end also. But the one that will get selected is the one whose clock lead is activated. So that's how it does activity selection. There are 25 different things here. Because I have 5 buttons. And this is basically like a ROM stack that stores which pistons fire for each activity. And this is the time delay section. It ensures that each piston fires at the correct time. Each one falls within a certain quantization of time. So there are 8 different intervals that are possible for each piston to fall into, and each interval is like about is 8 ticks long. So it keeps everything, keeps the pistons from firing into each other, keeps everything straight. These are the latches that control the pistons directly. This is the pulsar that I added on kind of as an afterthought that pulses rather than just simply an on or an off. And so this is the mechanical section. There are 8 pistons, I'm sorry, with 7 leads coming in. And this piece was the only piece I really tried to space optimize. I tried to make it as compact as possible because it has to fit behind the walls of whatever building you have. And it's also modular. That's the modular piece, and it's also scalable so that you can build however large a wall you want with it. This is the original prototype. Look how much smaller it is than the other one. It only has 4 states, but each button only does one thing, because each button, actually 2 things. It goes to a reset state and then it does its thing. So this is a much simpler design, and frankly I think it's more efficient. So if you're looking to build just basic light switch functionality, this is probably the way to do it. But the other microcontroller is pretty cool. Oops, where'd my cart go? I think I have another cart. And so now let's go downstairs, and I'll show you the Borg cube. You will be assimilated. Oh, here's my other cart. And what's the sun doing down here in my evil laboratory underground? Probably has to do with chunks not loading, and the moon. So we'll go upstairs into the inside of the cube, and I'll show you how they can all stack together. I've built a different kind of interface here. That has indicators out of glowstone with pistons. So it's in the off state now because there's no light, or there's no light because it's in the off state. Problem of causality. So we turn to level 1. This is the dimmest level, and I made everything slower because it has to do the same operations for all these pistons. So I increase the time quantization from 8 ticks to 16 ticks. So it's probably overkill, and I could probably make it faster, but I just haven't optimized it yet. And going to level 2, all it has to do is push that other piston up back behind the glass. So that was a simple operation from level 1. And then here's my indicator. And going to level 3, it's a little more complicated. It has to pull the glass out and then push the glowstone flush with the wall all the way. And that's the brightest level. So that's the scalability of this. Primarily the wall piece was the one I had to make scalable. So just could kind of do a little overview of just a flyover of the electronics for it. It's all in the dark. And here was my vertical transmission on the corner there. And that's it. Thanks for watching. Construxo signing out.